In this video we're going to look at estimating the Zener voltage just by using the power supply. Pretty straightforward, but it's a good skill I think to have. And so the only Zener diode that I pulled out because I want to use it in an upcoming video is the 9.1. So they use V for the decimal point, and unfortunately I bought this kit from eBay. They just hand wrote it. Some of these are pretty hard to read, but in any case, the number is also on the Zener diode. So that's the one I had. These other three I had on the board, I didn't know their exact values. And so I actually did this test, and I figured I would do it again in a video. So in any case, this circuit, it boosts voltage manually by pressing the switch. There's modules that do that. You wouldn't want to build it yourself really, unless you want to do it for fun. But in any case, current goes through the inductors there. It's set mostly by the resistors, but the inductors also have some resistance. And then when you let go of the switch, they want to keep current flowing. So they raise the voltage and charge up the capacitor, ultimately to a higher voltage than the power supply provides. So I want to use Zener diodes to limit that voltage. They work kind of as a release valve. So here I have a 220 ohm resistor, somewhat low value resistor, because we're going to be careful that we never apply more than about 5 volts maximum above the rated Zener value. So first we're going to grab this one. This one was already on the board. I had no idea what it was before I did this test right here. So now we have 1 volt, and I don't know why that keeps flicking back and forth. The circuitry up here is the switch is open, so that's not connected to anything. But in any case, this is, I already know it's the lowest value Zener that we have here, and then I think once we're above 1 volt it stops going back and forth. But there's 3 volts. Now you notice at 4 volts we have some current flowing, and we go to 5 volts, even more current flowing. So the Zener diode, when there was no current, was blocking all of the power supply voltage, and so I'm guessing it's somewhere around 3 volts right there. And we can go up here, we can see currents flowing. We can actually take a look at the voltage right now with the multimeter. So we just go across the Zener diode, and also Zener diodes are connected reverse bias. That's how you get the voltage. But there you can see 3.2, and we can see what it will be at higher currents, because the Zener voltage does go up a bit with current, but it holds pretty steady. So we can estimate, there you can see 3.4. So I bet this is actually a 3.6 Zener diode, but in case, we're in the approximate range. That is the main takeaway. So I already knew that this was the lowest value one, but these other ones, I would go through that same process of dropping down to, you can see the cathode there is connected to the resistor. Resistor goes to the positive rail. I would go through the same process if I did not know the value of the other Zener diodes. And so this is the other one of 4 that I already had on the board before I started making this video. And there we go. We went up to 7 volts before we started getting any conduction. So it's probably somewhere around 6 volts approximately. So there may be a little bit current, a little less than 1 milliamp. But in any case, we got an estimate. Again, we could raise the voltage and use the multimeter to get a more exact value, especially based on current. But we're just getting a quick estimate right here. And this is another one that was on the board. I think it's only about 0.5 volts higher. So I think that last one was 5. You can see 6 here we have current going. So I think this was actually the lower one. I think that's 5.1. So I think I had them in the opposite order of what I was expecting. I think this is the 5.6 right there. Yeah, you can't see any current, so pretty sure that one's 5.6. The last one we looked at was 5.1. And again, if I didn't know the value at all, I would go down to like 1 volt or something. The resistor here will protect most things from 5 volts current wise, including Zener diodes. So even 5 volts would be safe. But in any case, this is the 9.1 right there. I know because I grabbed it out of the bag, but I didn't actually look at the voltage on the part number, so maybe I put it in the wrong bag or something. You never know. So we're at the 9, and then we get to 10. You can see there is some current. So we probably got almost a volt across the resistor, because 10 volts at the supply, that's blocking basically 9.19 volts. And so there's 1 volt left to go across the resistor, and that is going to set the current. Also, this current isn't completely accurate, but it's usually pretty close. And so, of course, if we raise the voltage more, there will be more current. So that's another thing to be aware of. Higher voltages use a higher value resistor. But in any case, that sets the voltage right at that point in relationship to ground. So we could add more circuitry that heads back to ground, and that will be the voltage at that point in relationship to ground. It will hold steady as long as we keep the voltage above the Zener voltage.